Okay, here we are at site 1 of the Anity Burn. This particular location is as close to the source of this particular river that we can get. And what I'm going to be doing in this tutorial is giving you a series of points that you can use to analyze the data that you will have gathered from this particular location. Now, the first thing you will be doing when you get your data is you'll be exploring what your data says about this location. And if we just have a quick review of what you will be seeing in your data in regards to the 4 main characteristics that we are studying. The first one is discharge, and you will have found that the discharge is exceptionally low at this location. You will have found that the average rock size, as we can see, is very large. You will have found that the rock shape is very angular in general. And finally, that the efficiency of the channel is very low, that the channel is very inefficient or has a very small hydraulic radius. So what you now have to do is offer some analysis for these results. And what analysis means is it means that you give some reasons for the data that you are seeing. Now, because we are at the first location, we cannot compare this location to any previous site from which we've got data. So we can't say whether it is increasing or decreasing. We can only compare the data to what we have further downstream. So how does this site compare to sites 2 to 9, which we will be visiting later on? So let's start with the discharge. What is likely to cause the very low discharge that you're observing at this location? Well, the main reason for the low discharge is we're exceptionally close to the source of the Anity Burn. Therefore, there is actually a very small amount of surrounding landscape, which I'm just showing you, surrounding the river, from which water can be fed through the landscape to the actual river itself. And that's just bearing in mind that actually most of the water in a river doesn't fall in the river, it actually drains from the landscape. So because we're near the source, we're near the top of the drainage basin, and I'll put an OS map up on the screen so you can see where we are. You will see that there's only a small area of land surrounding this particular location from which water can drain, and therefore when it rains, this particular location will only capture a small amount of that water. There's also there's no tributaries joining the river upstream from this location, and therefore there's nothing else that could feed the discharge or increase the discharge. Right, if we now consider some other aspects, let's think about the bed load. Now there's 2 things we need to consider. The average rock size and the rock shape. So let's deal with rock size. Why are a lot of the rocks in the river channel very large at this location? And the reason for that is because at this stage they haven't actually traveled very far in the river, and therefore the process of attrition have not broken these rocks down, and they remain very large in size. Second reason why we've got lots of large rocks still in the river is we've got small riverbanks here where the river's slowly eroding away and rocks are released from the bank as it erodes away and falling into the river, or coming down the slopes gradually over time, because we're in a bit of a valley here, and those rocks are gradually over time working their way down through just natural slope processes into this river. But the bottom line is there's very little that's broken these rocks up, and therefore they by and large remain quite large in size. Now let's deal with the third factor, which is rock shape. And if I get up close, I can show you our average rock shape at this particular location is quite angular, and we can see this rock here has lots of angular edges. So why are quite a number of the rocks in our river quite angular in shape? And that's very for the same reason as why they're large. Because there's been very little movement of these rocks in the river, and that's also because there's very little water to move them, then these rocks haven't actually been smoothed and broken down by attrition, and therefore they remain quite jagged and angular at this stage. For rivers to become more rounded and smooth, they have to have travelled in the river for a distance to be worn down. And finally, let's think about our fourth factor that we are considering, which is the efficiency of the river channel. So we can see our river has a very low hydraulic radius. What that means is it's very inefficient. And the main reason for that is the river is very narrow, no more than kind of 50, 60 centimeters across, and it's very shallow. Now what this means is that the water is in contact almost all the water in the river is in contact with either the base of the river, the bottom of the river channel, which I can just show you, and or in contact with the banks. And because most of the water in this channel is either touching the base or the banks, that's creating friction, which is slowing the water down. The water is also colliding with huge amounts of rocks that are in the river channel. We can actually hear it just upstream. Because we can hear the water, that suggests the water is colliding with something, which we can see here. And that's also slowing it down. Other things creating friction in our channel is we've got a huge amount of grass overgrowing our banks, which is further creating obstacles in our river channel and also slowing our river down. So for those reasons, this particular location has a very low hydraulic radius, has a huge amount of friction. And what I've gone through is the factors that could explain the data that you're seeing for the 4 variables.